Hello and welcome to Unprofessional Engineering. My name is James.
And you got not civil engineer Luke Mahelsick.
Wow, well played. So I guess that's leading us right into things. We're continuing the series on the different flavors of engineering.
Is that called a spoiler alert, what I just did?
Yeah, you really ruined it. It's all good. Luke, tell me what is civil engineering?
Okay, so first of all, it is one of the most valued of all I can't even say it out loud.
I know.
I try.
It is very like a lot of different options.
Yeah, so it's super important, but for
Yeah.
some reason, and sorry, we're going to lose our entire civil engineering audience.
Yeah.
I haven't met too many civil engineers other than the civil sailor, our friend T-Dog, Trevor. I haven't met too many civil engineers that I actually get along with well.
Oh, really?
But,
Personally, you don't even mesh with them.
Yeah, they're kind
Interesting.
of like double E's a little bit. You know, they think they're better.
When they're definitely worse.
And when we find out they actually kind of are, we'll get to that later. But
Tell me about
sorry.
civil.
So civil engineering is a job where you, and I'm not going to read this. I have this memorized.
Yeah,
it's
well,
where
I know you do.
It's where they conceive. It's where they design, build, supervise, operate, construct, and maintain infrastructure projects, James, in systems that are both in the public and private sector.
Wow.
This could include things such as roads, buildings, airports, tunnels, dams, bridges, water systems, sewage treatment plants, basically
Holy cow.
everything
Everything.
that the foundation of human civilization relies on.
My goodness. That's impressive.
They're pretty important people.
They are important.
So
people.
like our stuff, you and I are mechanical guys,
We are.
right?
We are.
So our stuff goes inside of their stuff or it goes on top of their stuff. So if it wasn't for civil engineers, we couldn't exist.
I feel like if you're on top of the stack, though, you win. No?
Very good point.
Okay. Have you ever heard the saying that civil engineers build targets and mechanical engineers blow them
Yeah,
up?
I did hear that.
Yeah,
I think
feel
it was
that's
on like one of
accurate.
those like Adam Savage things or something like that is
very
where
good.
it came from.
Awesome. So it looks like you have a little bit of information on like the history or maybe how civil engineering got started.
Yeah, so basically it was a bunch of cats standing around that said, "Hey, we need to build something, and let's be consistent. Let's make sure it's not going to break. Let's not just throw a timber wall up in the backyard of my rental property and have it fall down 3 weeks later. Let's actually think about how to put things together, James."
Did that happen, Luke?
It did. I'm a little jaded, but okay. So one of the earliest examples of the scientific approach. This was using physical and mathematical principles to solve engineering challenges. So this was a cat by the name of Archimedes, or as I like to say, Archimedes.
That's the proper way to pronounce
Fairly
it?
certain it's Archimedes. And this was way back in the 3rd century BC. And he would use these principles of mathematics and physics to solve. In those days, it was kind of like super complicated. Like nowadays, it's like, relatively simple. But if you think about like how dumb people were back then.
The worst.
Yeah, Archimedes. Yeah. He didn't know what he was
He didn't
doing.
even know how to pronounce his name.
He didn't know how to pronounce his name. So Archimedes, I'll use the more common way of saying his name. He talked about things like the principles of buoyancy, things like the Archimedes screw, which I have no idea what that is. I probably should have looked that up hindsight, but that's a perfect example of applying principles to not engineering challenges, but more like development of like moving things you need to move or shoring systems up.
I feel like these guys, like Archimedes and Da Vinci and all of those folks, I think they just get credit for everything in their like area, like their time. Like if it was in such and such a year to such and such a year, this guy did it.
Let's give it
or
to
this guy did it.
yeah.
Like there's no way they came up with all this stuff.
I can't imagine.
Okay, continue on.
So back in the 18th century, the term civil engineering was actually coined, and it's not what you think it was. So there was tons and tons of military engineering happening back in the 18th century, shoring up castle walls and all that sort of stuff. I don't even know when the 18th century was. Apparently it was right before the 19th.
The 19th, yes, well said.
But basically, it was a term used to identify things that were engineered for civilian purposes, not for purposes for military, because really military engineering was really the only engineering that was really
Those were the two branches,
Exactly.
military or other.
Exactly. And that's where civil came from. One of the first private colleges to teach civil engineering in the United States was Norwich College. So this was back in 1819.
Well-known Norwich.
Exactly. Well known.
Do you know where Norwich is?
Connecticut, I believe.
Oh, okay. I don't know.
I'm fairly certain it's Connecticut.
Honestly, I have no idea.
And this was founded by Captain Alden Partridge. He's the grandfather to the Partridge family. Fun fact.
I'm sure he is.
I'm sorry, this is really off the rails today. The first actual degree program in civil engineering in the United States was awarded by the Rensselaer Polytechnic Institute in 1835. And the first such degree was awarded to a woman. A civil engineering degree awarded to a woman was a woman by the name of Nora Stanton Blatch.
Yeah, Nora.
This was, Nora, of course. Everybody knows Nora. Yeah. She went to Cornell, kind of like I almost did, my second choice.
You were close, yeah.
Second choice.
That was your safety school.
It was my safety school back in 1905. So it's nice seeing the ladies getting their civil engineering on.
That's
back in 1905.
Nice
I mean, you just don't think of. Back in 1905, if you just think about the culture of engineering, it was so male-dominated. Kind of reminds me of our Marie Curie episode.
Absolutely.
Where, she was, if you didn't listen to it, it's a good one. Check it out. But yeah, it surprised me that it was that long. I would have thought it was much sooner.
Yeah. So. I believe Cornell had something to do with the history of electrical engineers as well. Isn't that correct?
Yeah, again,
backup schools like that tend to do those sorts of things.
Yeah.
Well, that's very interesting. Anything else on the history of civil engineering?
No, not really.
Not really?
I'm sure there's a ton, but
You're sure there's a ton. All right, so what I focused on more is some of the subfields or subdisciplines that
I got a whole big list.
Do you want to rattle off some of your list?
You ready?
I'll tell you the ones that I focused on.
So when we talk about subdisciplines, so when you say civil engineering, generally, this is working at a high level. This is grading, drainage, pavement, water supply, sewage, dams, electrical communications. That's civil in kind of like the big high-level term. But then it gets like really nerdy and nitpicky. And I feel like this is like, if you say that you're an earthquake engineer, I feel like you're lying.
That's just made up.
Yeah,
I'm sorry.
Yeah, it's just like, come on. But so you got like coastal, construction, earthquake, geotechnical, surveying, land surveying, transportation, I heard is a pretty interesting one. Municipal or urban, I feel like that's just a civil engineer that works for a municipality. Really?
I feel like they're trying to feel more special than they are.
You know what?
And not to be mean.
No.
It's important what you're doing,
exactly.
I guess. Any other engineer could do it, but it's important that you decided to take that job.
Yeah. Water resource engineering, civil engineering systems, construction surveying. So I feel like they all fall into that big general one. And then depending on what you do as a civil engineer kind of determines if you're going to be an earthquake engineer.
I feel like the difference between a geotechnical engineer and an earthquake engineer is probably not a lot.
No.
And if you're being a structural engineer of the civil variety, then you probably are also accounting for earthquakes in that. So are you now a dual threat as an engineer because you're a structural and earthquake and maybe a geotechnical? I think it's all just made up.
I bet you Trevor rolled into his first job like, hey guys, I'm a earthquake engineer.
Probably did, but he was also like 14 when he did that.
He was.
All right, so before I dive into some of these subdisciplines in a little more detail and talk about the schooling and whatnot, let's take a break for a word from our sponsor.
I have to assume it's Cornell.
Cornell and Cornell? No.
No?
We don't actually have a sponsor this week, which is disappointing, but it is nice that we have just all the shout-outs.
I love the shout-outs.
All the shout-outs. Keith M. wrote in.
Good old Keithy.
He actually sassed me a bit, which you should like.
I love when people sass you.
An old episode I did with Dave, so it's cool that he's listening to like all of our episodes, so that's nice. But I didn't know how to pronounce someone's name, nor did I know if that person was male or female. If I remember correctly, it was Elijah something, and they invented the elevator, perhaps, if I recall the right episode. But then he had some very nice words about us and the great job we do. So Keith's okay in my book.
Thank you, Keith.
Charlie W. suggested we look into the Manhattan Project, which sounds like a cool topic.
I thought that was just a movie.
Well, that would be perfect for your research. You could just watch the movie, and I'd do everything else.
That's all I do.
Curtis G., also a fan of the idea of supersonic flight. This has to be like the third or fourth person that suggested it, so I guess we have to. to. And then Jordan D wants our input on going to school for engineering versus engineering technology. So clearly Jordan has misplaced trust in our opinions,
Yes.
don't you say?
Yes. Oh, no. Of course.
I haven't emailed any of these people back. I've really gotten behind on our emails. So I'm planning to this week.
I feel like one of these days we should probably take someone like Jordan, right? Some young, impressionable, excitable young engineer, maybe high school student. Probably have to be 18, so we don't have to ask their mom and dad if we need to talk to them. But let's say you're 18 years old out there and you're thinking about going to school for engineering and you want to be interviewed. You know what? Maybe we'll interview you.
I like where your head's at
I feel
on
like
this.
we could really give him some tutelage, some guidance, because clearly you and I are leveraging our engineering degrees.
Obviously, we are the right people to ask.
So make sure you subscribe. Make sure you write in. Get some stickers.
Yeah, if you want interviewed or if you just want to tell us what to talk about, email us at unprofessionalengineering@gmail.com. We'll hook you up with some amazing stickers. And then, like Luke said, leave us a review, subscribe to the podcast, get us famous so then we can retire. It's going to be great.
And make sure you share us, too. Something we don't talk about. Share us on social.
Oh, yeah.
If you see us on Twitter or Facebook, give it a share, give it a like. Don't just like on the YouTube or on the where you listen to the podcast, but find us on social and give us some shares and likes there, too, to help grow our audience so we can influence the future generations of engineers.
There we go. All right, so moving on to our subdisciplines. The first one that I looked into a bit was structural engineering. Still just civil engineering, but with another name. So this is like calculating forces and strengths and stabilities of all the big stuff that they build, like bridges and skyscrapers or like anything like that, right? And so the key here is the structure needs to be able to support its own weight, which you wouldn't think would be that big of an issue. But up until, not that long ago, relatively speaking, with materials becoming available, that was a big problem. Like more than one, 2, or 3 stories, and the thing was collapsing in on itself.
Yeah, when you build stuff with like wrought iron, a bridge, like the cat that did the Statue of Liberty, check out the episode.
Which isn't a bridge, but
previously he was using wrought iron and did bridges, and they didn't work out too well.
Do you remember who did the Statue of Liberty?
Good old Eiffel.
That's right. Good job, Luke.
My boy.
I'm impressed. All right, so this is also about the basics, like a basic statics class. Do you remember statics in school? No? Okay. So this is what all engineers take in somewhere in their first 2 years of engineering school. So basically anyone could become a structural engineer if you're an engineer, because this is so basic. Reinforced concrete designs would be another big class that you have here, because instead of just dumping concrete on stuff like civils do, sometimes they stick metal in it as well to really make it complicated. Any problem in civil engineering, it's like, uh-oh, my building's going to fail. Dump more concrete.
Rebar.
Stick some rebar in there.
Yeah.
Oh, my road's not working. More concrete. It's not a real hard solution. I know. Let's see. Rumor has it there are labs. This is cool. There's labs that you actually get to pour the concrete and you pour it over the rebar, and then you do loading of this thing to see the kind of stress that it can hold, to understand the properties of the different rebar options and the concrete and things like that.
That would probably be one of the more cooler disciplines to kind of get involved with, because I feel like it, at least from a learning perspective, it's probably hands-on quite a bit. I would think.
I would think that too, but I feel like a class like that probably isn't offered everywhere.
Yeah.
I mean, maybe bigger schools have that, but I don't know if everybody's out there pouring concrete on rebar. Structural dynamics is also an important part. So again, this is how buildings or structures react to earthquakes or wind or other natural forces. If you haven't, check out our episode all about earthquakes, as well as the one on skyscrapers and why they don't fall down, thanks to civil engineers. So that's, something you could do.
Thank you, civil engineers.
That's right. Other options would be seismic analysis, bridge building, mechanics of materials, and timber structure design. So these are some of the class options you would take as your electives if you were focusing on structural engineering. Timber structure design?
I feel like that's
catching.
I feel like it's catching on. I've watched a and not related to this podcast in particular, but I've watched a couple videos about over in Europe. They're creating wooden skyscrapers, and they're doing this, for renewable purposes, and the way they're building them is like amazing. And I think the biggest challenge was like fireproofing them during the construction process.
Yeah, that seems like a problem.
And like when they're in use. But apparently they can treat the material certain ways and have fire suppression. But I think the whole wooden structure thing is kind of interesting. It looks really cool too.
It does look cool, but I don't know about that. I don't trust wooden roller coasters either. Ugh, not safe. Okay, moving on. Geotechnical engineers. I'm going to try and work through these ones a little bit faster. So one of my friends is a geotechnical engineer. He's a civil. He basically doesn't do anything. He's very open and honest about that.
He works really hard at work.
Somebody goes out, takes a core sample, they send it back there, and they go, that looks like good dirt to me, and that's his job. It's amazing. He used to take the samples, but he's no longer allowed to do that. So, worried about rocks and soil? Not real hard. So, this is what a lot of civils do. The structural engineers don't really worry about this, so they're creating more jobs for other civils. So I'm going to build this big building. Hey, you, go look at the dirt first.
Make sure what I'm setting it on is going to hold it.
Exactly. And so this actually is a problem, because if you think about, the residential building in San Francisco that's literally sinking into the ground, and nobody is really claiming why it is. Like, some people say it's because of the subway system nearby, or some people say it's because of the foundation not being deep enough. These are the kind of problems that these geotechnical engineers are supposed to be solving, which clearly they don't. Leaning Tower of Pisa is another example. Probably Pizza is the most famous example. And we actually talked about that and how they pumped foam underneath it to kind of prop it back up so it doesn't tip over. So that's nice. Just a lot of investigating soil. There's actually a class where you walk around and you pick up rocks and dirt, and then you take that back and do some tests on it. So you have to figure out, what kind of property does sand have, or dirt have, or gravel have, or whatever.
Okay.
So that's something. Water resource engineering, and this is one that's near and dear to our friend Trevor's heart. I don't think he listens to us.
That's his speciality?
I think technically it is.
Okay.
So what do these people do? They basically take poo water and make it clean again. And I mean, they do other things, but that's really the gross part of what they do. So they also design various hydraulic structures like dams and sewage and things like that. They make waterways. Lots of different applications like hydroelectric power development would also fall into a combination of civil, both the structural and then the water resource engineer, and then irrigation and canals as well. This can be used for soil and groundwater contamination and floods and all of that stuff. And classes would include, very interesting, coastal hydraulics, open channel hydraulics,
of course,
which would be kind of like our fluid flow that we would take, except that they have an open channel that it's going through.
Gotcha.
And I have some fun facts about this, thanks to our friend Trevor, later on in the show. Sweet. And the last one I want to talk about, and then I'll let you speak again, Luke, would be transportation engineering. And this is, like you talked about, the designing of streets and highways and roads and other public transportation systems, and maybe even airports. Though I guess airports have everyone involved in, right?
Yeah, they
got
everybody.
So they're also concerned with how new developments will affect roadways and the traffic patterns. So if you check out our episode on livable cities, that's kind of like a potential civil engineering job where we look at how this new housing development or a new stadium or something is going to affect the traffic patterns, and are the roads able to then handle that, both with respect to size and speed and exits, on ramps and off ramps, things like that. They determine how merging on roads happen. So in Pittsburgh especially, we hate them because the merging here is terrible.
Yeah, we have about 7.5 feet to merge onto a highway whose speed is 65 miles an hour.
Yeah. It's
everywhere.
It's amazing.
It's terrible.
Maybe civil engineers weren't around when they made our roads.
Yeah, it's part of my rant. It's coming up here in a
good.
minute.
They add bike lanes to normal roads, which is another reason I dislike them. But one thing that's interesting is this is considered the least math-intensive field of civil engineering.
I'm in.
Which is the least math-intensive field of engineering. So if you just are terrible at math, yet somehow you get through all of the required calculus classes like differential equations anyways, this is the field for you.
And you like drawing curves that represent roads.
Right, exactly. All right. So with that, before you go on with all of your information, and I think we're going to get into like schools and money and things like that, let's take a break for this week's Luke's rant.
So this rant is directly related to what we just talked about, transportation, folks. And our good friend Paul had a request for a show, and this is my rant.
Oh, the show's the rant?
We're going to do a show
Listening
on this.
to Paul's the rant.
A little bit. You know that accent. So the rant is roundabouts versus intersections.
Oh.
So Paul suggested that we do an episode on the differences, the efficiencies, and I've driven in. There's a few places in the United States that have roundabouts. There's some smaller towns, newer developments that have adopted roundabouts. And I just don't know how Europe is all roundabouts, right? And we came from Europe, essentially. So the Pilgrims came over with their cars, designed roads.
I think so.
You know, like how...
For the first Thanksgiving.
Exactly. Like how, like when you're driving to the first Thanksgiving, you know, why did they do an intersection instead of a roundabout?
Maybe they hated roundabouts.
I don't know what it is. It's just, so roundabouts, from my understanding, and I've watched a video or two on it whenever Paul made this suggestion just to see if it was interesting, they are so much more efficient. And even at like a massive, like interstate level, like if you watch these videos of interstate roundabouts versus typical interstate on-ramps, and you know the decrease in accidents, and you can maintain your speed. I mean, I don't know why we don't have roundabouts. And you would think with new development and you know new highways and infrastructure that we would be integrating roundabouts, and we just don't.
So you're pro roundabout.
I'm very pro roundabout. Okay. There's a couple places near D.C., Chevy Chase, Maryland, that I've driven through, and it's just tons of roundabouts, and it is so easy to get around and maintain your speed and get to where you need to go without stopping at a stop sign.
Some of my in-laws live in an area that, well, maybe they lived there. I can't remember. It was either Cleveland or Columbus, and they had a roundabout.
Columbus has a lot of roundabouts.
Then it must have been there. And it was fine. It's fine. I could see why people get confused or have trouble with it when there's the multiple lanes going through and which exit. And it really gets kind of funny if you have to listen to Siri give you directions. And she's like, take the next right. And you're like, is that the one that's immediately right here? Or is it the next one? So that's kind of tough.
So my rant is we need more roundabouts, and it's a plug for a show.
There we go.
To roundabouts versus intersections.
That's a good one. All right, moving on.
So let's talk about the monies.
Cash money.
Because that's all anybody cares about. So our shout out, that cat that sent in, that's what he cares about, right? He wants to know how much change, how much bank he's going to make.
Bank, yeah.
So this is not starting. This is just the average. So keep that in mind. And you have a slightly different number because yours is PA specific, but this is the national average for a civil engineer is $68,431. That's national average. Crazy enough, James, the national average for a mechanical is only $75,158.
Is that so?
Both of these are according to our friends over at Glassdoor.com.
Sponsor
Not
us.
A sponsor right now, but could be a cool way to...
Maybe we should
get
them up.
So they literally make like $11,000 more nationally on average. And I find it hard to believe, and I don't know if that's just because civils tend to specialize maybe a little bit more than mechanicals, and that warrants it, but...
That's interesting. So unlike normal, I actually have a little more information on this.
Yeah, that doesn't happen very frequently with us.
So civil engineers that are just fresh out of school in the Pittsburgh area average about $65,000 a year, but that range is 47 to 85. This is 3% below the national average. So all of these numbers I give you are going to be about 3 to 4% below because apparently we don't get paid enough in Pittsburgh.
There's just not a lot of civil engineering firms in Pittsburgh.
I guess that's true. 1 to 3 years, you average about 67. So you really get like no raise in that time.
$2,000.
Yeah. Civil engineering, 4 to 6 years, you're up to about the 78. And now probably where the average comes from is that 7 to 9. You're at about the 88,000 mark. Then you get into the higher paid ones because you've worked forever. 10 to 14 is at 96,000.
Not too shabby.
No, and then you end your career 15 plus around the 108 to 130, 140,000. So you're not doing bad.
That's livable.
That's
right?
livable. Yeah, I think that's okay.
I'd take it.
I mean, let's be honest, it's not podcast money.
It's not.
But
Good
it's
point.
livable, yeah. All right, moving on. How about where do you get this education?
So it's crazy. And so I listed the top 5 schools, and for once, CMU and MIT are not on it.
MIT's not on the list, and that makes me happy.
It makes me so happy.
That's because civil engineering's beneath them.
Exactly. It is. So like every time we do a best schools for anything, it's always MIT and CMU are up there. And I love they're not on the list. So number 1 is University of California, Berkeley. So if you're out of state, this is going to cost you about $43,000 a year. And if you are in state, it's only 14. So it's a bargain if you're in state.
It is
like
a bargain.
Killer
it really
bargain.
is. So this one's also always on the list.
Yeah.
Berkeley's always on the list. And for electrical, we had similar numbers, and in-state again, just a steal. Go there.
Yep. So none of this includes housing. This is just tuition and fees.
Yeah. You can live on the street in California.
Next up, rolling in at number 2 is the university, let me say that again.
Georgia Tech.
Georgia Tech. And Georgia Tech comes in at 33, so that's out of state. So you're about $10,000 cheaper than the best school. So I feel like if I was going to do it, that's what I would do.
More bang for your buck, right?
Way more bang
Pay
for your buck.
housing, too.
And about $12,000 if you're in-state. Number 3 is University of Illinois Urbana-Champaign. It's so classy.
It is.
You're about $32,000 a year for out-of-state, $15,000 in-state.
But their football team's terrible.
Oh, yeah. Well, they're always drinking champagne. They're
That's
always
probably
drunk.
it.
University of Texas, Austin, $37,000. They're a little pricey for coming in at number 4, but their in-state is only $10,000. How do you go to school for basically $40,000 a year? That is, so you could go to school in-state in Texas for what it costs for 1 year of out-of-state. What are kids thinking when they go out-of-state for college?
I know.
They're dumb.
Well, one thing that I guess is like a mini rant is a lot of schools like CMU have a super high out-of-state acceptance rate because they charge $8 trillion.
Yeah.
They also charge a lot for in-state, but still, it's so much higher that they tend to do that.
It's just crazy.
Unbelievable.
So like the number 5 too, Purdue in West Lafayette,
A reasonable 28.
So number 5, it's only $28,000 a year out of state. In state, it's also $10,000. So that means the number 4 and number 5 schools, if you live in those states, you can do a 4-year degree for what it costs 1 year.
That's nuts.
As a parent, so this is a plea to all parents listening. Do not let your children go to university out of state unless they have a scholarship. It's stupid to spend that kind of money. Sorry. Wow.
I'm with you, and I'm not a parent, so.
I know.
So I think you have a few other things. I have maybe 10 or so fun facts you might not know. Which one would you like to do first?
Let's do your fun facts because I got the top 3 civil engineering examples of all time. Maybe that could be like our crescendo.
Ooh, I like it. All right, so this is from our friend Trevor. If you haven't checked out Concerning Reality on the YouTubes or the Facebooks, go and do that, and he will, hook you up with some.
He does some
sweet
really
content.
cool videos.
Yeah. So these are things that only civil engineers know, according to Trevor. They know things like how many different types of cement there are, like Portland cement, high alumina cement, white cement, sulfate-resisting cement, and many, many more.
I don't care about any of that.
Nope. Civil engineers know that there are 4 types of road curves: simple, compound, reverse, and deviation.
Still don't care?
Nope. They know the equations to do those too, which sounds pretty easy to me. Concrete never dries. Did you know that?
No, but I don't care.
Don't care? Okay. The minute size differences between silt, like 0.05 to 0.002 millimeters, sand, 2 millimeters to 0.05, and clay, less than 0.002 millimeters.
Not caring.
Oh, okay, well, I'm trying to impress you here.
I know you are.
They know that sewage has to flow over 3 feet per second in horizontal pipes, but they also know that if it flows too fast, like 12 to 18 feet per second, dangerous gases can be produced, and everyone has a bad day because of it.
That I'm starting to care about.
Yeah, that impacts me, so I'm glad they know that. Civil engineers understand understand what the different external patterns on rebar are for each kind, like European rebar, carbon steel rebar, epoxy-coated rebar, and so on. I didn't even know there were other kinds of rebar. But now that I think about it, they do have like those weird shapes on them. So I don't know why they have it, but civils do.
What I know is rusty rebar when it's been sitting outside too long.
There's a lot of that.
Non-rusty rebar.
Those are the two main types to keep in mind. Yeah. And last but not least, Luke, the cone of depression is a depression in an aquifer's water table when water is drawn out through a well.
Aw, maybe if you just be nice to it, it won't be so depressed.
Right? I love the name, though. That's like my favorite civil engineering term now. All right, let's hear your final wrap-up.
Okay, so we can't talk about civil engineering without doing like an all-time civil engineering project. So I found a pretty comprehensive list. There's about 25 of them, and surprisingly, the top 3 were like ancient things that were done. And we actually have an episode on one of them. Oh. So number 3 comes in the aqueducts of
Segovia.
I don't know how you say it. You nailed it. So this was back in 50 A.D., and you've seen pictures of this. It's basically those overhead aqueducts. It's 167 continuous arches. They're all kind of broken down now. And there's over 25,000 individual blocks that were used to create those aqueducts. And just think back, and then we talk about how dumb these people were back then. Like, how did they do this?
Well, that just shows how easy it is to be a civil engineer. This is one of the top projects.
Once again.
And they did it this long ago?
Number 2, I can't believe this one was number 2, but the Great Wall of China. Think about, what goes into that. So this was 475 BC. This thing's 5,500 miles long. In some cases, it's up to 25 stories tall in certain areas, and it's literally still standing. So this one's pretty impressive to me. So I get that. And then coming in at number 1, and check out our episode, is the Great Pyramid. It's 450 feet tall. It's 756 feet at the base. There's over 2.3 million individual blocks in the Great Pyramid. And it's estimated there were over 30,000 workers that were working on this at any given time. And some of the largest blocks, now this is where mechanicals get the shout out. Some of the largest blocks were 25 up to 80 tons, and a civil engineer is not going to design a cantilever to lift that block. What they do, they say, whoa, we can't do anything. Let's get some of these mechanical engineering pharaohs in here. And then then you and I show up in those skirts and funny hats.
And those skirts and those neat hats, yeah.
And we show up
with our cat.
And we're like, you know what you need? You need a fulcrum. You need a really long lever, and you
nailed it, man. You nailed it.
Seriously.
A couple of points about all this. One, we did an episode talking about both the Great Wall of China and the Great Pyramid.
Both? Okay.
2, the Great Wall of China, not real impressive when you're on it.
Yeah, you were on it.
Yeah, I mean, the length of it, very impressive, but the size, like height, not so big, and it's all falling apart, Meh. 3, all of these things, basically, go pour more cement. Meh. Yeah. More cement, fix the problem. Civils.
Yeah.
I think it is fair to say that we love you, civils.
Oh, we do.
We pick on you out of our insecurity.
That's exactly. They make more money than us.
That hurts.
It really hurts.
Wow. Well, hopefully everybody got a lot out of this one as well. We're getting close to them being able to decide just what type of engineer they want to be when they grow up.
Yep.
Well, until next time.
See ya.